The simplest of the collision resolution protocol is the aloha protocol designed at the University of Hawaii in the 70s. Basically, the protocol is very simple. When a frame arrives for transmission, the user simply transmits the frame and waits for an acknowledgement. If an acknowledgement arrived, we're done. We know that the transmission of the packet or the frame was successful. Otherwise, we wait a random time and go to 1, namely transmit again. Note that if two users transmit at the same time, their transmission overlaps, both transmissions are garbled, and none of the users is going to get an acknowledgement for its transmission. In this diagram, we see an example of how aloha is working. Time is flowing this way, and each rectangle represents a transmission of a frame where the left end is the transmission of the first bit and the right end is the reception of the last bit. So what you can see here is 5 users using the same channel. User E is transmitting successfully its first frame, and then users D and C transmit with an overlapping period, so both their frames are collided, and we have multiple collisions here. And then if each of these users is picking a random time for each transmission, and as you can see, user E was successful, and then D and C, and while the A and B are still trying to transmit their own colliding frame, user E managed to transmit a third frame in between other user frames. So what we can see here is that these things can work. However, bandwidth is not necessarily allocated fairly among the users, because as you can see here, user E managed to transmit 3 frames before user A managed to transmit even 1. So think of constant size frames. All frames are size t. So if my red frame is transmitted starting at time t0, it will be successful if nobody is going to transmit while I'm transmitting, but also if nobody is going to start transmitting up to t time units before I started transmitting, because then I will collide with the tail of its transmission. So we have a sensitive period of 2t times. Using this observation, we can calculate the throughput and see that the maximum achievable throughput in an aloha protocol is only 18% of the capacity.